Hello everyone, this is new subject for the group ML-19. This is the practice subject. We're going to solve practical problems, math problems of high school, and try to explain them in English. We will be considering only problems. So in the beginning I want to mention that I will put under the video some difficult words and phrases that may be hard and difficult to you to memorize. So please pay attention. We stopped at functions lessons. We're going to solve problems about functions. So the first problem says that we have f of x function equals to x squared minus 3x, and we have to find f negative 2 plus f4. What does they equal to? So the first thing that we will do is we substitute negative 2 and 4 into the equation, into the function. So we will put negative 2 onto the variable x. So we will get negative 2 squared minus 3 times negative 2 equals to 4 minus negative 6. And as we're subtracting here minus sign number, we will change the sign to plus, okay? 4 plus 6 equals 10. So the next one is f of 4, substituting 4 onto the x. So it's 4 squared minus 3 times 4 equals to 16. 4 squared is 16 minus 12 equals 4. And the last thing is we're going to have to find f of negative 2 plus f of 4. So we will add the numbers that we got. 10 plus 4 is 14. So function means not only f but also other letters. G of x is also a function. G of x equals to 2x plus 1 over x squared minus 1. We have to find g of 2 and g of 2a. So it's just not just a number, but 2a with a variable with unknown number. We put 2 into the function. 2 times 2 plus 1 over 2 squared minus 1 equals 2, fraction, 4 plus 1 over 4 minus 1. 2 squared is 4. So it equals to 5 over 3. Simple as that. So the next one is 2a. G of 2a equals to 2 times, we're putting 2a into the x's place. So it's 2 times 2a plus 1 over 2a squared all together in one brackets minus 1 equals to 4a plus 1 over 2a squared is 4a squared minus 1. We will stop here, no need to simplify. So these are the answers of our problem. Next problem, we have function g, which represents z to z. Z is integers. So x can get only numbers from z. So it's only integers. We have function g of u. Variable is u here, not x. U plus 5. We have to find g of 0 and g of negative 0.5. I'm going to find negative 0.5 first. So it's undefined. It has no answer because z is not negative numbers. It can have only positive numbers. So it's undefined, no solution. The next one is g of 0. We put 0 to the place of u. So the answer is 5. Next one is a function. It's a system. It has many functions in it. So the first one is 3 minus x if only x is greater than 1. It's a conditional function. Second is x squared plus 1 if this condition is x has to be between minus 1 and 1. Last one is 2x if x is less than negative 1. We say conditions like this. If chosen value x is more than 1, then substitute it in 3 minus x. If the chosen value is between minus 1 and 1 inclusive, then substitute it in x squared plus 1. And the last condition is if chosen value x is less than negative 1, then substitute it in 2x. These are the conditions. So we have to find f of 0 plus f of negative 4 plus f of 10 equals what? The question. So since x is between negative 1 and 1, we substitute 0 into the second function, x squared plus 1. So it equals 1. The next one is minus 4. Since it's less than minus 1, the third condition, we substitute it in 2x function. Do you see here? So we get f of negative 2 is 2 times negative 4 equals negative 8. Next is 10. We have to find f of 10. So 10 is greater than 1. So we put it in the first function, 3 minus x. 3 minus 10 equals to negative 7. So the final thing, we have to add them all. So 1 minus 8 minus 7. We have to remember that plus and minus sign gives us minus. So it's negative 14. The next problem is we are given a function f of not x but 1 over x, so it's a bit different, equals to x minus 1. We have to find f of 2. What do we do here? We have to make 1 over x equals 2. So we have to make sure that 1 over x will be equal to 2. To make it, we pick 1 over 2 in the denominator of this fraction. So 1 over 2 gives us just 2. So we did find that our variable is equals to 1 over 2. And now we simplify this complex fraction. 2 skips to the top, and we get f of 2. So we get 1 over 2. So we're finding f of 2 equals to 1 over 2 minus 1. So the final thing is f of 2 equals negative 1 over 2. Because 1 over 2 minus 1 gives us negative 1 over 2. So the next problem is a little different. We're given a graph, not a function. So they gave us a graph and they didn't tell us what function it is. So it looks like this. I'm illustrating a graph from the book right now. So the question is two questions, A and B. A asks us to find f of negative 2 plus 2 f of 3 over f of 0. So 2 right there is a coefficient. 2 in the front of the f of 3, you see? Now, as you can see from the graph, -2, as you can see, when x equals to -2, y is 0. So the value is 0. Next one is 3. When x is 3, y-axis is -1. Follow the graph. The third one, f of 0, is 1. So we substitute all the numbers onto the place. From the B section, they asks us to a condition f of x equals 0. So in order to find when the function equals to 0, we are finding when this graph intersects the x-axis. So here it's -2 and 2. The graph intersects with x-axis. It means that when the function equals to 0, the values will be these points. So it's -2 and 2. Guys, it's a little mistake here. The answer will be from -infinity to -2, and then 2 to +infinity. The next problem is about graph also. We are given a function f of x equals to x minus 2, and they gave us domain of x, so what numbers we have to put onto x, is -2, -1, 0, 1, 2, 3. So what will we get if we put these numbers into x's place? Calculate in your mind, guys. When x is -2, it equals -4, right? -1, it's -3. If it's 0, then -2. If it's 1, it's -1. 2, 0, 3, 1. We will use these points in Cartesian product. When it's, for example, the simple ones, when it's 3, y equals 1. When x is 0, y equals -2. These points we will use, and this kind of straight line we will get. So this is the graph of our function. The next interesting thing I want to mention is that you see the 2 steps to the right side, because it's x minus 2. The function is x minus 2. Then it will be 2 steps to the right side. If it will be x plus 2, the graph will switch to the left side, to the negative numbers. So the function will be shifting up and down, right and left. The next question is, they are asking us whether this is function or not. Just look at the graph and tell me if it's function or not. To know it, we will be using vertical lines. We will just imagining vertical lines from the left side and from the right side. If it intersects at just one point, you see here, just intersecting in one point, then it's a function. If it will intersect the graph in more than one point, then it's not a function. So we're given in the next problem is circle, not ideal, just random circle. And can you see it intersects in not just one point, it intersects in 2 points. So by rule, no, it is not a function. The next graph looks like this. So we're using vertical lines in our mind. It intersects not just one point, it intersects in 3 points. So it's not a function. The next graph looks like this. this is the axis, guys, x-axis and y-axis. So our graph looks like this. It has some pauses in the middle. No matter there is a pause in vertical science, it intersects in just one point, so it is a function. So the next problems will be about domain. We already solved problems about domain. Domain, as you know, it is a set of numbers that will take variable x, right? So in the A problem, we're given a polynomial x squared plus 2x minus 8. Polynomial takes any number, so the answer will be domain equals real numbers. Real numbers is all the numbers. So B, we're given a function f of x equals to 1 over x plus 2. And as we taught, we look at the denominator of the fraction, it shouldn't be equal to 0. So x is not equal to negative 2. Or else, it will have no answer, right? We can't divide a number into 0. So domain of this function will be any number, but just not negative 2. It will be negative infinity to negative 2, union from 2 to plus infinity. C, we're given a function f of x equals to square root of 2x plus 1, and an expression under the root can't be equal to 0. So 2x plus 1 should have to be greater than or equal to 0. 2x is greater than or equal negative 1. X is greater than or equal to negative 1 over 2. To write an answer, I want to show you in the coordinate, in a line. So as you see, negative 1 over 2 is inclusive, and all the numbers that is greater than it. So it's negative 1 over 2 to plus infinity. The last one is D. We're given a function f of x equals to, now this is not a square root, this is cubic root of x minus 7. So cubic root means any number because it can be negative number. Because, for example, negative 2 cubed equals to negative 8. So it's okay. It can have any real number. Domain will be any real number. Oh, we have one more example here, D. F of x equals to 1 over 3 minus x. It's also a fraction. Minus 4th root of 2x plus 7 plus x cubed minus 5x. It's a long function, and the thing that we consider is the expressions under the root. So it's 1 over 3 minus x and 2x plus 7. We will combine these two expressions. So the first one is should have to be greater than or equal to 0, and the next one also have to be greater than or equal 0. So look at the first expression. In order to be our expression 1 over 3 minus x to be greater than 0, the denominator of it, 3 minus x, have to be greater than 0, because positive number divided by positive number gives us positive number. Next one is 2x plus 7 greater than 0. We go further and x is less than 3. 2x is greater than negative 7. We're going further and x equals to negative 3.5. Negative 7 divided by 2 is negative 3.5. So again, in order to write an answer, I want to show you in these answers in coordinate line. So what we have is x is less than 3 and x is greater than or equal negative 3.5. First, we will write negative number and then positive number. We will show you by painting the intervals. Negative 3.5 is inclusive, that's why I'm painting it. Painting the inside of this dot, and I'm not painting the inside of 3. So the domain will be the intersection of these two paintings. So it should be inclusive, negative 3.5 to 3, not inclusive. So that is it. I sent you similar problems. See you soon, friends. Bye-bye.